Hello, I'm Umnik. I will be doing education at the first round, and I'll try to explain what I'm doing. Haven't done screencasts in a while. Actually, I don't think I participated in any contests last week. So might be a bit rusty. I don't know. In problem A, have some kind of a game. Initially there are n integers on the blackboard. Each integer is 1. On each turn, the player chooses several equal integers and write down a new integer which is equal to their sum. If a player cannot make a move, the player wins the game. It feels like if n is big enough, then Alice should win by choosing all but 2 ones in the first move, and then we will have 1 1 and minus 2, and the only move for Bob is choose 1 1, and then Alice will have 2 and minus 2. So if they're different, which is true if n is at least 5, then Alice will win. Maybe we have examples or something. So if n is 2, then the game will end after first Alice's move, so Bob will win. If n is 3, then independent of what Alice's move is, Bob will win, because again he doesn't have any valid moves. And if n is equal to 4, Alice cannot take all 4, Alice cannot take 3, she can take 2, but then Bob will take the other 2, and then Alice has a valid move. So if n is at most 4, then Bob will win. Otherwise, Alice will win. What just happened? Let's try again. Okay. Problem B. So there is some operation to define beautiful array. An operation is to remove several, maybe 0 elements from the beginning and insert to the back. That's cyclic shift, right? In the same order. In such a way that the resulting array is sorted in non-decreasing order. So the array is beautiful if it is a cyclic cyclic shift of a sorted array. Okay. Arrays that consists of 0 or 1 element is beautiful. Okay. So we start with an empty array. Process Q queries. In each query we are given an integer. If we can push back that element so that the array stays beautiful, we do that, otherwise we don't, and we have to print whether we did or did not. So while the array is sorted, it is beautiful. So at first we will have like some sorted prefix. Then we can try and sort the number that is smaller than the last one. And if it is also like not bigger than the first one, we can do that. So the array will stay beautiful, but then like there is only one cyclic shift that can possibly make it sorted, because like we need to split that pair that is in the wrong order. So basically from that point on we need to check if the suffix is sorted and like all the numbers we inserting are not greater than the first element. So we don't even have to store everything. We only need to store like the first number, the last number, and whether we are in this stage when like we already have this down movement once. So we'll have first, last, and the next element we're trying to insert. Ans will be a string that we have to output. So we read the first element, say that the corresponding answer is true, and then n-1 times we read the next element. So we will have two different cases whether we are in the first stage or in the second. So here's the first stage, and if x is at least the last element, then we will push it back, and we will stay in the first stage, and the last element is now x. Otherwise, if it is at most the first element, so it is strictly greater than the last, it is strictly smaller than the last, and maybe it is smaller than the first, then it is fine. Otherwise, we don't add it, and nothing changes, obviously. But here the first element doesn't change, obviously, the last element changes, and we will move on to the second stage. In the second stage, we will insert the element if and only if it is between the last one and the first one. Not random numbers. Okay, it's like Roman numbers. but not really. We have letters from A to E. They are just powers of 10. The values of all digits are summed up, but some digits taken with negative signs. A digit is taken with negative sign if there is digits with a strictly greater value to the right of it, not necessarily immediately after it. So the digit is taken with positive sign if and only if it is non-strict maximum on the suffix. So if we're going like right to left, A is maximum, so like +1, then +100, +1000, -10, -1, -1, -1, and +1000. So we are given a string of those letters. We can change at most one letter, calculate the maximum possible value. Well, it is very straightforward DP. I don't even want to think more about it. Like as I said, if we're going from right to left, we only care about the maximum digits we have seen. So the DP will have state like the suffix with reversed, what is the maximum digit we have seen, and whether we used this one change that we are allowed. With that fixed, we want to just maximize the value. And we need to be careful because the answer can be negative, I think. Well, yeah, sounds like the answer can be negative. And the answer can be what is the largest number we can get? It's the length multiplied by 10 to the 4th, so it's 2 times 10 to the 9th, which is like okay for integers. My infinity will only be used as negative infinity, and the smallest negative value we can actually get is just 1000 multiplied by this with minus sign, because all the e's are certainly positive, so it's fine. Also need like the powers of 10. So initially we have traversed 0 symbols. We can say that the maximum we encountered is 0 because it does like well, it is kind of like minus infinity, but the 0 is fine because we care about like non-strict maximums, and we haven't used our change of digit, and we have 0 here. This is actually needed because otherwise I can like start from invalid situation and I can add like a lot. I think that is needed. Like, maybe not. Maybe it is not ever helpful to start in invalid situation. So let's say I want to place digit with value equal to x here, then I have to use an operation if x is not equal to c, if new value of f is at least 2, it's bad. So if x is smaller than the maximum we encountered before, then it will have minus sign and it will not change the maximum. Otherwise it will have the plus sign and it will change the maximum. Or maybe it will stay the same, but like x is at least m, so it's fine. And then update dp I plus 1 and f. Because the value is not x, but the x's power of 10. Yeah, that's more like it. What is going on? So okay, we have some segments on the number line. Segments are intersecting if there is a common point, borders included. An array of segments of length k is called beautiful if k is even, and it is possible to split the segments into pairs. such that every segment is an element of exactly one pair. So the segments in each pair intersect, but the segments in different pairs do not intersect. So like that split is unique, right? Like for every segment there should be exactly one other segment that intersects with it, and that's necessary and sufficient condition. And given an array of n segments, remove minimum possible number of elements so that the resulting array is beautiful. It kind of seems like maybe like DP on like what I want to do is to like choose the intersection points. We can choose intersection points, and for each intersection points we need to leave like exactly two segments containing that intersection point, and then we have to remove all segments that intersect with either one of them. Or maybe just not intersection point, but just the chosen segments. Like DP, where basically we're going left to right. So let's sort the segments by left border, for example. And I want to store like what was the last segment I have taken. And when they're sorted by left border, then each pair will be like two consecutive left borders. So like I have like two different states. The last chosen segment is the first in pair or the second in pair. And the first in pair, it's kind of easy, right? Like I know that all my previously chosen segments are somewhere, like they ended before that one started, and I only will look at the segments that started after that. So I'm just iterating over the segments that I will pair this one with. And like take them and update the DP. But for the second one, like actually storing like that last segment is not good because like I need to make sure that none other segment like I will take later intersect either of those two. So what I actually need to store is like what is the first place I can go to now. Um, well, I can either do like exactly that, or just like um, just store DP in the like those of segments who has right border. So it's like the one that has bigger demands. No, in any case, I will have to store two DPs, but probably like in the first way is kind of simpler to understand, but I will need to compress coordinates and well, it's not hard obviously, but in the second way I don't have to do that, and I don't think it's like harder, so why not do that? Okay, so I think it is easier to do GP forward. Since like I'm only doing transitions to the right, but the next segment I'm choosing will be the one to the right, but I can like when I'm taking one segment and the next one is inside, I can go to the state like where this is that's the segment that bounds me on the left. So I can go from GP1i to GP2i. So I first have to do transitions of the first type and then of the second. And also every time I can just take this segment as the first one. So I know that the segments are sorted by left border. So I need to stop doing the transitions of the type when they're no intersection, and if they're intersecting, then I can do the transition, and I will do the transition in J if its right border is more to the right than the right border of I. And in I otherwise. here I need to start the new pair, so it should not intersect the segment I'm talking about here. So if it does intersect, then I don't do this transition, otherwise I do. Problem E. Square matrix n by n and n is big. Okay, cells are black or white. And in each column, first AI cells are black and then all the others are white. So all the black cells are like pushed to the top. You want to place m integers from 1 to m. There are two rules. Each cell should contain at most one integer, and black cells should not contain integers. So place integers in white cells, at most one integer in the cell. The beauty of the matrix is the number of such j, that j plus 1 is written in the same row in the next column as j. So like to the right. What's the maximum possible beauty of the matrix? Kind of a weird problem, isn't that? Like we're just taking like horizontal segments of consecutive white cells, and we want to take a small number of segments as possible, such that their total length is at least m, so that if we like enter numbers in that order, like in every segment consecutively, then the beauty will be like m minus the number of segments. So we just need to understand what is the longer segments. Sounds kinda easy. There can be a lot of segments. Maybe that's the issue. But like there can be a lot of different lengths of segments, and n is not that big. I mean big, but not that big. So like I think that I can like go from top to bottom, and like at some point there will be new white cells like at first I think that everything is black, like in the zeros row that doesn't exist, and then I'm moving down, like doing this kind of scan line, and then in some columns the cells will become white, and I can maintain the set of segments I have, and for every segment, like I know when it started, so from that point up until I merge it with something, uh, it is like it exists, so it will contribute that many white segments of its length. And then for every length, I'm calculating the number of white segments with that length, and then like this counting part is super easy. Okay, kind of. I don't know. The second last problem in educational round. It's usually much harder than that, I think. Alright, so I'm going through the events. That's when like black cells stopped in some segment, in some column, and so that column is X. And I need to like look to the left, to the right, and if those columns already exist, then I need to merge them, and for the segment of like to the left, to the right, add to the count like the number of segments with that length. So if the segment to the left exists, then we're saying, okay, its left border yeah, I can actually do it like this. So for our new segment, currently left border and right border is X. It's just one cell long, but if this one exists, then the left border will be this left border that is stored in the cell because it's the right border of the segment. And I'm saying that sin t of length is x minus L should be increased by t minus the time that starts there. And now the same thing for the cell to the right, but now with the right borders. Now I know that my new segment is from L to R, and so I remember that the right border in the left border is R, and left border in R is L, and in both of them the time of creation is this t. Now I can finally read M. Now we are iterating over segments in the order of decreasing length, and for segments of this length x we have sin tx of them. So we are looking at how much of them do we actually need. That's like m minus sum divided by x but rounded up. But we only have sin tx of them actually, so we will take only minimum of what we need and sin tx of them. Then we increase sum by k times x, but decrease ans by k. That is incorrect. Right, because in the end everything is just one segment, and so for n I need to add like n minus the time of creation of that big segment. Still incorrect. So I'm saying that there is 5 segments of length 5, 9 segments of length 4, 6 here and 3 here. Yeah, makes sense. And I need 20, so it's 5 plus 5 plus 5 plus 5. Oh, for this one I have the right answer. I don't have the right answer for the second one. Second is this one. One of length 4. They need 5. Should be 3. How is that possible? I probably like get some negative k, so I need to stop when I already have my m. Yes, that's a stupid mistake. Okay, the last problem F. Okay, so we have some city with 4 races, and they're split into pairs where in every pair one race is antagonistic to each to the other, hostile, and each inhabitant has happiness value. It is the number of creatures of the same race living in the town, excluding that one, minus the number of creatures of the antagonistic race. So like if we have X humans and Y orcs, then human happiness value will be X minus 1 minus Y, and orc happiness value will be Y minus 1 minus X. But we can take that minus 1 because it's just like minus 1 for every creature, and then all the other things, like if we just sum the happiness up. Okay, I guess I need to read the statement till the end, but if the total happiness is just the sum of happiness, then it will be like X minus Y squared. The beginning is not inhabited. During the game, and groups will come to the city. The is group. Okay, so we can accept the entire group or reject the entire group. The game calculates mana carp score according to the following formula: m plus k. M is the number of inhabitants, and k is the sum of happiness. So like m plus k, m will actually kill that -1 we get from every human. So okay, it is a geometry problem, and probably not very hard at that one. So so the score is a minus c squared plus b minus d squared. So we can just say that a minus c is one coordinate and b minus d is the other coordinate. So we are given like a bunch of vectors. We can choose some subset of them. Then we sum them up as vectors, and our final score is the square length of the sum of the vectors. That's x coordinate squared plus y coordinate squared. Right. So we want to choose vectors with largest total sum. Okay. If we fix, if we guess the direction our vector will be in the end, then obviously we just want to maximize the projection on this direction. So we will just take all the vectors that have positive or non-negative projection on this direction, and we will not take any vectors that have negative projection on this direction. So for fixed direction, we just simply take the vectors that have non-negative projection. Now let's not fix direction, but let's try all of them in this sweep line fashion. So we will rotate the direction we are choosing, and we will maintain, so we will sort all the initial vectors by angle, and then when we rotate the chosen direction, we will choose all the vectors that are in half plane, that is perpendicular to this vector, and when we rotate the direction vector, those half plane will also rotate, and we can do just 2 pointers on this thing and just update the answers. Okay. I mean, it's a cute problem statement, I guess. But okay, I guess that I should have some snippet. Yeah, that looks right. Well, they say it in the statement, the answer is integer, but it is rather big. It doesn't fit in long, so I probably need to be just a little bit careful. We'll use this big integer, int 128. that should be fine. Okay, the reading is actually kind of a bit stupid. Well, I can just read 2 points and say that it's their difference. Let's do that, yeah. Because I will do like this cyclic sweep line, I need to copy the points. I think 1 copy should be enough, if I will be careful about that. Actually, like I can update the answer every time I'm choosing some valid combination of points, even if I know that it is not optimal, because it's still a valid combination of points. Yes, that should be enough. So now I need to move either one or the other. Actually, I should no. Yeah, well, with points on the same line, it is a bit tricky. I need to be careful. Like, guess like this comparison should be like strictly greater or the line on the same line and they're looking in the different directions. Yeah, also, and that can also be like 0, 0 vectors, which are not great because I don't know how they will be sorted, so I need to remove those. That's just great. is equal to Q, it's also okay, also should move Q. And I can just write it as a cycle on P. Yeah, I'm not doing great job at showing off how you should write it. What's wrong? Mm-hmm. Okay, let's print double. Humans, orcs. So I cannot read it like this. So it's x minus y and z minus t. Okay, now it's working in samples. Yeah, I'm not sure about that, so I will. Yeah, not a great showcase of how to write that, but what? Oh, right, I need to choose the 64-bit compiler. Doesn't even work. They have. Yeah. If I'm in the middle of the group that has the same direction, I will be screwed. Hmm. Can like merge those groups. Oh, this is really bad. So my vectors are sorted by angle, so the groups of the vectors that go in the same direction, they're consecutive, so I can find those groups that going in the same direction predicate. And then I can take their sum because I know that I only choose vectors based on their direction, so vectors with the same direction, like I can bundle them together. And they still should be correctly sorted. So should be fine. But I'm not. Maybe the problem is something else. Oh, now after I did that, the vectors can become very big, so I also need to make this big int. I have a feeling that I will spend a lot of submissions on this one. It's okay. Probably for the best. Probably I should go through this. Am I? I don't know. Actually, I don't need this anymore. Oh no, I still do. Yeah. It's not even close to correct. Well, what? Um, okay. Okay, so should be working. 0, I will just print 0, right? Um, 0, then this will be bad, but it doesn't matter anymore. Okay, that was amazing. So I did plus plus in 2 places because like I thought about it like a while with 2 pointers, but I wrote it as 4. That was really stupid. Like amazingly stupid. Finally. Yeah. Not my greatest work today. But I got there in the end. Thanks for watching. Bye.